Hi, welcome back. Today we have Rob Green with Patchwork. Please take it away.
All right, thank you very much. So, and the remote that I have is not working. So, all right, we're gonna go like this. Hi everyone, I'm Rob. This image that you see here was generated by Claude 3.5 Sonnet, I believe. 3.7 was not out when I made these slides 2 weeks ago, but I think a lot of the things are going to apply almost exactly the same. I asked Claude to generate a cartoon-like image of a bald man with a black shirt, smiling and waving, like that. And I think really it did a pretty good job. It made an SVG, but can you see anything that's wrong with the picture? Yeah, one hand, right? Now, this does a pretty good job sort of summarizing what you get out of naive LLM usage. It's close, but there's something a little bit wrong. So LLMs are not always great at designing perfectly cohesive solutions, meaning that it'll accomplish a few tasks, but when you look at the whole end-to-end, some of the parts from the beginning might not actually match up with the end. It can't always think through the consequences of a design. Meaning that it'll give you working code, but sometimes there's some really hidden troubles in it. And one particular problem is that sometimes even in a single file, it will generate code that uses different versions of the same library, so that code couldn't possibly compile and run the way it is. And it also doesn't always fully understand your intentions. Now, LLMs are actually very good at talking to you in your natural language because they're trained in your natural language. They're pretty good at just making up stuff. Like they're making up some data, making up a function you might need. They're great at mimicking examples. So if I say, hey, here's an example of a thing, can you now apply a different style to it and do the same thing? It's pretty good at that. And they're excellent at copying things they've been trained on. And that's really key. I think most people know all this by now, anyone who's been using them. So when trying to use an LLM to write a smart contract specifically, rather than list the exact problems, I'd rather show you an experience I had going into it as a naive developer with my prompt. So I wrote this exact prompt. I said, write me a smart contract that is a game item system. Make weapons with modifiers where the modifiers can be purchased and assigned to the weapon. Make armor sets where the armor pieces, again, are purchasable individually and then get assigned to the armor set, but these can be unassigned and traded separately again. I got a little wordy, but I figured that's how people talk to them, right? And so it says, yeah, great, I'll make you a smart contract system. And so what I'm expecting to see is something like this. I mean, I think I said I want to be able to buy the modifiers separately, right? So we would think they should maybe be 721s that I could maybe buy on OpenSea, and I want to be able to assign them to the weapon. And same with the armor. I want to be able to buy pieces and put them on an armor set. So I think this is reasonable expectation of what my prompt would have described. But it didn't do that at all. And I'm not going to show all the code it generated because it generated a couple hundred lines to try to create this. And it made it very bespoke and non-standard. And I said, no. Make it so that everything is a 721 and that there are different contracts for each type of thing. Because it tried to make one mono contract that had all the things and had a purchase function that something would know how to call and all types of stuff, even though I explained that. And it said, okay, I'll split it up. Good, we're getting somewhere. And then I got a contract from that, and I noticed that when I had an armor set, that it didn't consider what happens if I sell the armor set. It didn't consider that those armor pieces maybe should also belong to the set. That means when I sell the set, it should belong to the new owner. And I said, all right, I want an armor set that when sold applies the new ownership to all the assigned pieces of armor, right? And it goes, okay, I'll cascade the ownership, right? And it did. It wrote that. Now we started trying to compile, because this is just me getting the code back and looking at it. And I noticed that I was trying to compile it with OpenZeppelin 5 and the latest, which has been out for a while, and some of the code didn't work, and it said, oh, you're right. I used OpenZeppelin v4. I'll update it for v5. And I said, okay, it gave me code. I tried to compile, it still failed. So I pasted the errors in. It said, right, yeah. In OpenZeppelin v5, things changed, so I'll update that for you. And I was like, okay, good. Finally, we're going to get past this. So it gave me new code. I pasted it in. I'm like, what? Can you just fix this, please? And it goes, sorry. I guess in OpenZeppelin v5, something changed again. And I'm like, we talked about this, right? I thought we were using v5. You can't get this. Okay, let's go. more problems. And it goes, I see. The issue is that I'm still not using OpenZeppelin v5. This is really my interaction with I kept taking the code, try to build it again, same thing. This just continues. Here, again, it's like, oh, okay, well, now in OpenZeppelin v5, something changed. It's now virtual, I gotta change it. And I'm like, okay, well, let's keep going. Still can't compile the code it gave me, and it said, okay, we're getting somewhere. We just need to make sure that we have the right imports, that we have we're now using the hooks. And finally, it generated code that compiled except for the test, and I looked at the test code it generated, and it literally concatenated an old version of the test it generated and a new one, if you can see it. So I just hand copied that off and said, okay, we're not perfect here. And after 28 iterations with 3.5, I finally had working code, right? So we're all good, right? It was a little bit more work. It would have been nice if that had been an agent. You would have just watched it loop 28 times and do the thing instead of me telling it. But at least we have some code, right? So we're good. Well, the problem is that once I got the code from it, I looked through it, and I realized that what it generated for me is largely unusable. It never asked me how I want the mints to work on these 721s. It just sort of made an assumption and ran with it. And what I wanted, and what I sort of would expect a system to be able to do, is to offer some form of self-service, meaning a user can show up and they could go to mint.fun and create something, or maybe they could maybe we just have something where there's some payable mint function or something and they can buy the item they want. But it sort of assumed that I was just gonna mint all the items myself and put them for sale myself. And that was, an assumption that I didn't want self-service. One huge problem is that it had zero logic to check. Again, it generated working contracts. It generated working tests. Everything passed. But it had double assignment errors, where if I had that armor, like I was talking about, there's an armor set. If I assign those pieces to one armor set, I could mint another armor set and assign the same pieces to it, and then the cascading ownership would break when I transfer the second one. So it was really a broken contract. There was no data-driven setup for the mint strategy, so I couldn't say I want it so that this is a helmet and it costs 0.000333 ETH or something. I couldn't do anything, and then a ton of minor issues. But after all those 28 iterations, I still have to start over. I have to make new contracts because these aren't going to work for me. The biggest issue is that the LLM itself does not understand the greater architecture required to build safe, efficient, and interoperable contracts. And some of this is pretty specific to smart contracts, because there's a lot of great examples out there, but you have to get awfully specific if you want it to actually work in the way I was just saying. Like if I want there to be data that gets pushed to it to configure minting, and I want users to self-service. So a person running into these problems might assume that, well, the LLM just didn't have enough context, right? The logical next step is, let's refine the LLM usage. Let's tell it the logic in detail that we want to have. Let's give it examples. Let's give it more context, and let's refine the core prompt. Surely I can prompt my way out of this, okay? That's logical. Now, if you do that, the good news is that you're going to significantly improve your output. It does work better to refine your prompts. But the bad news is that it's still just grabbing and generating contract code out of nowhere. You still have to manually audit every single line. Not just audit, you have to think through logical minds that are going to be in there, like that double assignment problem. A lot of people wouldn't notice that, and I'm sure it had other problems I didn't notice as well. And you're only going to find out after you deploy this code, right? And it's questionable if this is better, that whole process is really better than just manual development for one-off contracts that you're going to make. It might be safer to just do it yourself. So you saw the prompt that I had in the first place, right? I posted that. This is my refined prompt. I'm not going to read it to you, but you can see it is full of technical details. I'm explaining exactly which function I need to have. I'm telling it what modifiers to put on it. I'm telling it data types to use for things. I'm giving it rules. I'm saying only use OpenZeppelin v5. I'm saying make sure that you can only assign a weapon modifier to one weapon at a time. I'm saying make sure that only the contract owner can actually add weapon configurations. I'm giving it everything, and I'm giving it an example contract. This is what I mean by refining your prompt. You literally have to go this far in order to one-shot something or even get a few shots of response to get something that is what you want. And you have to think through this ahead of time. So it's kind of a pain, right? So I'm going to propose today that people consider a hybrid approach. All right, I'm going to call this the 80-20 approach. I'm going to say that you should either use an existing library or existing software, or develop, if it's really custom, develop procedural code generation that does about 80% of what you need done. Let's say you're an app and you're going to need 40 different smart contracts. It's an asset system or something, and you've got all these classes of assets. I think that you're better off generating 80% of the code for those and then only customizing the little bits that are really different, unique, or different logic with each contract, either by hand or with an LLM to do that, right? And if you do this, the LLM's requirements go down substantially. It no longer has to account for your overall design. You're doing it. You can give it really detailed context on what it needs to have. You can give it the exact logic that you need, and you can give it an example, and your prompt will be smaller, and it will do a much, much better job for you because it doesn't have to do all of it at once. It can just focus on the custom logic that you need. This approach is applicable for projects that have lots of contracts, or where lots of different but sort of similar contracts, or groupings, classes of contracts. Right? Now, if you want to develop code generation tools, the general process is first, you need, either manually or using an LLM, you need the correct code. So it's just fine. I mean, prompt away, get the code that you need, audit it, make sure this is right. Then templatize it. Take that code that it made, refactor it a bit, make it so that you have just those reusable sections within a template, and then now you can just generate the contracts, and it's always that audited code you're getting every time, right? Add some tests, and you're guaranteed it's deterministic, and you're going to have success. So you might say, no, that's not what I'm interested in. I think that we just need LLMs to get better and better at doing this. They will, right? This sounds like a very old school approach because it is. But the reason that it's not a bad approach is because it's highly effective. The output you get is deterministic. And not doing this, the alternative is typically I made a couple of contracts and I copy and pasted those to these others, and I changed the logic and I copy and pasted those. We've done that at our company, and I can tell you that we almost always forget something or another, and we have funny little bugs here and there, sometimes not severe, but copy and paste is only so good. The bad news is it's upfront. The upfront cost is pretty high, and if you're trying to make one or two contracts, this probably isn't the best approach for you. Right? So if you're interested in this, you could say, well, what things are really good to generate procedurally? Things that are going to be conventions across a group of contracts. Let's say you're going to have many contracts that are mintable. Well, the mint functions that you might want to have, the relations that are going to be, so if my contract is going to relate to this other contract, generating the code that enforces the relationship is great. Anything involving the mint strategy, so I can upload the same way to tons of different contracts I have. Just anything you see repeated across contracts is a good candidate for procedural. So if you're wondering, well, how do I go there, though? How do I actually do that? Well, this is a project configuration that we use. What we're doing here is, if you can kind of read this code, this is just some JSON that is showing, it's not JSON, this is TypeScript, and it's showing that I have some contracts, I have a character, I have a game item, they have these, like here's a model, I've got these fields they need to have, this one, we have a thing called fragments, it relates to this game item here, so my generator can look at this and it can say, I know there's a relationship between game item and character, I will generate the code to securely manage that relationship for you, I know that you want these fields of these types, I will generate code that can handle the bits of security that you want for access to those things. Right? So the way a workflow works like this is, first, you need to make that app configuration, something like I just showed. Then you pipe it through a procedural contract generator. I could speak. There are actually many out there that you can use. You will get some generated contracts, but those generated contracts are going to be missing some of your custom logic. So you take that generated contract, you give it a refined prompt, you put the two together through the LLM, and now you have a final contract where you only need to audit the diff between the generated contracts and the LLM generated parts. It's significantly easier to do, and you get far more security and much higher chance of success with your code gen. So an example post-generation LLM prompt, like I showed you my one before, paragraph, lots and lots of logic rules in it. This is an actual one you could do. I could say, now that I have a generated contract, I could say, modify the contract given to add the following functionality. A weapon modifier increases durability or damage of the weapon it is attached to. So it'll add some code when you assign that weapon modifier, it'll modify the weapon. And then I want to say only one of each weapon modifier type may be attached to a weapon at a time, and here's my generated contract. Your LLM now has a very high chance of success. It can see where it needs to go, it can see how everything's already laid out, it doesn't have to do any guesswork, and it can probably generate this code just fine, and you can probably audit it just fine. So we have a full implementation of tools that do code generation. We're not the only ones that do that. But if you want to take a look at any of this stuff, we have a system called Patchwork that takes that configuration and does all of that. If you're curious or have questions, please join our Discord, and we'll help you out with anything that you're trying to do. I'll leave this up here for just 1 second in case anyone's interested. Also, I'll provide a link at the end too. And the future of code gen, ultimately, we all know we're heading toward no code. We know that in the future, it's going to be plain English that you're going to use to write your software. Things like smart contracts may stay special case for quite a while because of the general permanence and because of how big a blast area is when you have a bug and how sometimes you just can't fix it. It's on chain. You're done. But we know we're going toward no code, and I think the real question, though, for us engineers is, what does that look like under the hood? We know the user experience, but under the hood, is it just a sea of agents, or is there a bunch of hybrid stuff under there where we're making specialized frameworks for agents to use as tools to give us secure generated code? And I think it might be something like that. There's a link to the slide, some resources, and whatever you need. And I'm a little bit early, but that's all I've got. So thank you very much.
No, thank you. Appreciate your conversation out here. So, well done.